Sorry, part 1 got caught off a little bit, but where we left off, we were plugging in 1,366 in for that 7th term. So when we times that by 4, we get 5,464. And when we subtract the 2, we end up with, oops. Okay, so that's our 7th term there. Okay, so remember, we always have to plug in. That's the thing with recursive. The formula is not so hard to make, but as we try to get bigger terms, it takes a little bit more for us to get there. So you always have to plug in. You always have to have some term to plug in to keep moving forward. In 8, it tells us to factor completely. So first thing I'm going to look to is 3 terms. I'm going to see if there's a GCF. So with each of these, we can pull out a 3x squared. So then I'm left with 6x squared plus 7x minus 5. So we got rid of that GCF first. Now we're going to rely on our headphones method to help us here. So headphones, remember, we take 6 times -5. And you could have done it with the 18 and the -15, but this at least gives us smaller numbers to work with because we know that would get us -30. You can always look into y equals to try to break this up. Remember, y equals -30 divided by x will show you all the factors. So something that multiplies to a -30 but adds up to a positive 7x is going to be a positive 10x minus 3x. And then we drop down the 6x squared and the minus 5 to make it into grouping. So I'm going to pull out a 2x. We get 3x plus 5. And we pull out a -1 and get 3x plus 5. So we'd end up with 2x subtract 1. 3x plus 5. And we're not going to forget about what we had in the beginning here that we factored out first. 3x squared. Notice I'm not solving in any case here because it didn't ask me to solve. We wanted the factors. So that means we leave them in the parenthesis form. That is factored completely. If it said to find the roots or the solutions, then I'd set each piece equal to 0. But that's not what I'm asking for here. I'm just trying to factor as much as we can. Okay, so 9's broken into a bunch of parts for us. First, we want to figure out which part is equivalent. So they're basically setting up our factors here. So if we look, 4 terms again like before, we're going to try to take out any factors we can. So in the beginning, I see we can take out an x squared. And we'll have 6x minus 5y. And here we can pull out a -4y squared. And we'll get 6x minus 5y. Things are good because our parentheses match, so I'll check if that is our equivalent one just yet. And it is. So which expression is equivalent to? It's really going to be choice 4. Now, it's saying a little bit further we want to know the factor, so I'm going to keep going with what I had up here. And I'm going to put the x squared minus 4y squared in one parenthesis. And we have 6x minus 5y in the other. But remember, this first one can factor further. We have dots again like we did before. So x minus 2y, x plus 2y, and 6x minus 5y. And we're going to see which parentheses match and which ones do not. So circle all that apply. So it's a little bit different than our normal multiple choice. So any factors we're going to circle. Not choice 1. It was when it was a minus in between. And 6x minus 5y, so not this one, but 3 works, 4 works, and so does 5. In something like 10, we have the zeros of a cubic function are -5 and plus and minus 3. So on the set of axes, we're going to sketch this graph. Things we want to keep in mind: cubic. That automatically tells me it's degree 3, which makes sense because they gave us a total of 3 roots, like 1, 2, and 3 here, because of the plus and minus. Now, it just said a possible cubic function. It didn't say the cubic function. There's not just one answer that makes this work. So we can do this any way we want in this case. Now, when I go to sketch this, I'm just going to put my axes on. You don't have to be perfect, but I'm going to plot those 3 here of -5. I'm going to label because that is important to us. We're going to have -3 and +3. Now in this case, I have no indication where my y-intercept would be whatsoever, so I'm not even going to stress out and try to find it. All I really care about, if it's degree 3, then it's opposite directions. So I'm going to make my curves so that they hit all of them, and that's one possible cubic function. I could have done the same thing. So this gets me full credit, just having the labels there, the axes, perfect, and the numbers all gone. I could have also switched it up and made it negative. So I could have started up and done that. Either one of those two things will get you full credit because there's no rules here. It doesn't tell me where the y-intercept is. It doesn't tell me. We just want to sketch up a graph, a possible graph. Now, is there an absolute minimum or maximum or neither? This one's going to be neither. An absolute max is like a highest point, just like an absolute min is the lowest point. Unfortunately, because of these arrows, that means they go to infinity and negative infinity, and we don't know exactly absolutely where to get to that spot. So we're going to say neither, and we would explain that if it's going to infinity, it's not an absolute top spot. Like right here, this would be a relative maximum. Relative because out of perspective wise, it is a max, but not the absolute, not the highest point overall. Okay. Last page as we go through here. What is the value of f of -4? So remember, we go to -4. Okay, if I plugged in x as -4, we would get 0. F of 1, we go up to our graph here, is up at 2. So what does this tell you about x plus 4 and x minus 1? Well, x plus 4 is a factor. It had a remainder of 0 when you plugged into the function. This is not a factor because it was not equal to 0. Now, big one here. We have had a lot of trouble with this one in the past. Remember, this sign means inverse. We switch x and y. What I mean by that is if I start with f of x and rewrite it as y, my first move in this case is to rewrite it as x equals 2y plus 3 over y subtract 5. Now what we can do nicely in this case is stick x over 1 so that we can cross multiply. So after I cross multiply, I'm looking at 2y plus 3 equal to xy minus 5y. Excuse me, 5x. And now our goal is to get y back by itself. So I'm going to move anything that has y to the same side. So I'm looking at 2y subtract xy, and I'm going to have -3 subtract -5x. I'm going to take the GCF out here and get 2 minus x equal to -3 minus 5x. Last step is to divide. Now, you could have done all the same steps and had the pieces switch in a different order, like 5x plus 3 and x plus 2, or x minus 2. That's okay. You can have them written in a different order. That is totally fine. As long as you did all the same steps, it should check out. But just don't forget to rewrite that piece as the F inverse equals our final answer, because that notation is important, that you're showing that you were clear of how to do this. Last one. So explain what it tells you if x plus 3 is a factor. Well, in the interest of saving some time here, you know that we would show that we plug it in the whole way, like negative 3 to the 4th plus 8 times negative 3 to the 3rd plus 11 times negative 3 squared minus 32 times negative 3 minus 60. We're going to plug that in and get 0. And what does that tell me? I would write out that it tells me it's a factor because it had a remainder of 0. Now, in this next part, we are using that factor to figure out another factor of this. So we're going to do reverse tabular because we know that it should divide nicely. X plus 3 is down the side. X to the 4th. 8x to the 3rd. 11x squared. Negative 32x minus 60. As we go through this, so we slide that x to the 4th in. X to the 3rd times x would get me x to the 4th. We'd have 3x to the 3rd outside here, down the bottom. With the 8 outside, we want a total of 8, so we need 5x to the 3rd. So then we keep the process going, so we want 5x squared on top. We'd get a 15x squared when we multiply that with the 3. We want 11, we have 15, so we're going to subtract 4x squared. And we get negative 4x here with a negative 12x. So we still need negative 20x more. And when I multiply it, negative 60. So it checks out that there's no remainder, that it's a factor. What's nice about this as well is that we see 4 terms. So we probably feel that it's going to nice and factor by grouping nicely. I'll pull out that x squared and get x plus 5 minus 4, x plus 5, x squared minus 4, x plus 5, and we factor. So that's me algebraically showing the rest of the factors. So that's 3 of the factors, but don't forget that magic word, all of the factors. So I'm going to pop down x plus 3 from the beginning, what we divided by. That is a factor as well. To finish off strong, we set each piece equal to 0 to get all of my zeros. Notice there's 4 solutions.